Okay, what we want to look at here is I want to solve some equations that turn out not to have the situation where you find out exactly the one point or the one number where they have a solution. One of them would be like this. If I have 3x minus 9 is equal to 5 times x plus 3 minus 2x minus 24. How does this work out? Well, 3x plus negative 9 isn't going to change very much. Right, I'm going to put in my plus sign, and it's minus 9. But what else happens? Well, we got this. Equals 5. We know we got 1x inside the parentheses there. That's about it for the ones. So we're going to have 5 times 1x for 5x plus 5 times 3 for 15 with no x. And then these two guys. And the process that you go through next with the parentheses gone should be known to you by now is to combine like terms on each side of the equation. There are no like terms on this side up to the equal sign. 3x is an x term, minus 9 is or negative 9 is a number term. But here we got 5x, 15, negative 2x, and 24. Negative 2x joins the 5x, negative 24 joins the 15. Now what happens here is this is 3x plus 9 equals, and now we have 5 minus 2 for 3 with the x's, and we have 15 plus negative 24. Subtract 24 minus 15, you're going to get 9 stronger on the negative, and you're going to have this. So when we go through this, we now start saying, let's get rid of the worst bank balance. That's a 3x, that's a 3x, it's a tie. So call one of them the worst bank balance, and let's subtract 3x off each side. Turns out they both go out. So now we're going to have, oh sorry, this is a negative 9 right here. Nothing monumentally off-putting about that, but we do have that as a negative. Because what's about to happen now is I say, okay, now I've got these numbers, and I can leave them where they are, or I can add 9 to both sides. So I'm going to leave them where they are, and I'll get this thing negative 9 equals negative 9. And when we find the solution to an equation to be a single value, we got what I call as a sometimes or even a one-time solution, what number works. And that means it only works when what I say is true. So if it comes out to x equals 5, it works when x equals 5 and no other time. This one is saying this works only when negative 9 equals negative 9. That's all the time. This is when does negative 9 equal negative 9, that's always. And that means that our solution is going to be all real numbers. Any number will work. That's another situation, if you've seen one in the homework, where any number you put in there, the two sides will be equal. So if you put your lucky number in, the two sides will be equal. I don't know what number it's going to hit, but I know it'll hit the same number on both sides. So here's another kind of one where the x terms will drop out and create a situation for us about when is it true. And let's take a look at 4x minus 8 plus 3x is equal to 7x minus 2. All right, so there's no parentheses, and we've got to combine like terms. So what I've got here is I need to put in plus in front of my negative 8 and a plus in front of my negative 2, and let's see what happens for like terms. 4x plus negative 8 plus 3x, that's another x term. We're going to add the 3x over here, and that'll get for us 7x plus negative 8. That column is used. Over here we have no change, so now we have 7x plus negative 2. And so now we're going to say, let's get rid of the worst bank balance. There's a 7, there's a 7. I guess one of them is the worst. We'll get rid of 7x on each side. And this will go out, and this will go out. We're going to have negative 8 equals negative 2. So I'll ask you, when does negative 8 equal negative 2? This thing was always true, so all real numbers will work. This thing is never true. No numbers work is what's going on. And so while this is called the solution is all real numbers, this one is called there is no solution. I don't care how long you look for it, you're not going to find a number that makes it so that negative 8 will equal negative 2. And so those are the two odd cases that show up when our values, where the columns of what x is supposed to be, drop out and they leave you something that's always true or never true. And that's how we can get our solutions all the time or none of the time. So now we want to get into what we're looking at here. We want to clear fractions because this problem can be a real hassle. I want to show you it is possible to do it with the fractions and why it's such a hassle. And then I want to go right next to it and show you how we're going to do this thing called clearing fractions. Get ready. Here's an equation. 2/3 x minus 5/4 equals negative 1/6. With a fraction calculator, this is not too bad, but let's see what we can do if I don't have a fraction calculator and I don't know how to clear fractions. The interference, let's see, there's my x, here's a number, there's a number, no x over here. That's a positive x, which is better than a negative x. I'm going to keep that, and I'm going to get rid of the negative 5/4. So here we go, 2/3 x plus negative 5/4 is equal to negative 1/6. What I'm going to do is add 5/4 to both sides to get rid of it. And this will definitely be gone. This will leave me with 2/3 x equals. And now I have negative 1/6 plus 5/4, which now that needs me to have a common denominator. It's not 24, it's going to be 12. But that one's going to be negative, and this is going to be positive. This is going to start with negative 1, this is going to start with 5. I'm going to go get my multipliers to get the 12 as the denominator of each one. New 12 divided by the old 6, I need to double both of these guys, so that's times 2. 12 divided by 4, I need to triple each of these, so those are times 3. What's that make for me? It's now going to make for me negative 2 plus 15 over 12, which is going to equal 13 over 12. So now I'm going to have this thing over here. 13 over 12 is what I get the 2/3 x to be equal to. Now what do? I have my 2/3 x, I leave some space behind it, and it equals 13 over 12, and I have some space behind that. And I'm going to figure out how I'm going to get rid of multiplication by 2/3. I'm going to multiply it by 3 over 2. Okay. So now, when I go through this, let's see. I'm going to come out of here with 3 times 13. Oh, let's do some canceling here. 13 over 12, no reduction. 3 and 12 each divide by 3. 12 divided by 3 is 4. 3 divided by 3 is 1. We get 13 times 1 over 4 times 2. And therefore this becomes x is equal to 13 over 8. Let's check that out. 13 over 8 in there. 2/3 times my number minus 5/4 is supposed to equal negative 1/6. My number is taking its way in as 13 over 8. Therefore, we have divide by 2 for 4, divide by 2 for 1. We've got 13 over 3 plus negative 5 over 4. Oh, 13 over 3, no, 13 over 12 minus 5 over 4 is supposed to equal negative 1/6. So we need 12 to be the denominator of each. And 12 divided by 12 gets me a 1 here. That doesn't change. 12 divided by 4 gets me tripling on each of these. What do we get then? We have 13 over 12 and we have negative 15 over 12. That works out to 13 plus negative 15 over a single 12. Subtract for 2, strong on the negative, over 12. Divide top and bottom by 2. Negative 1/6, and it does hit the target. That's what you have to do if you don't have a fraction calculator and you don't have the ability to clear fractions. I want to grab my fraction calculator. It's the $8 to $20 calculator described in a video I sent you to look at. And what we do with this is when it's time to combine things like -1/6 plus 5/4, what I'll do on this, I'm at the point where I have to add these guys, and I'm hoping to turn it up and have it make for me the 13/12. Well, let's see what happens. If I take a negative number, you either have to go, if there are parentheses around your dash on your calculator, I guess that's common in a Casio, and here I have a TI, I'm going to have to put my 1 in and make it negative. So you're staring at -1 before you put it in a fraction over 6. Hit the ABC key, and then put it over 6. Now I'm looking at -1/6 plus 5/4. So do plus 5 ABC4, and I'll hit equals. Now this says 1 dash, it says 1 and then 1/12, which is what 13/12 is equal to, but I'll hit the second key here. It might say INV. Sometimes it says other things, it's often a different color. And I'm gonna go hit my ABC key again, and that tends to be the one that'll put it into the format. And now I got my 13/12. So I knew that 2/3 x was supposed to equal this. I grabbed my calculator and it got me the 13/12. Now I'm looking at this and I realized that I want to multiply both sides by 3/2, right? 3/2, right as that's sitting here. So I'm going to go ahead and multiply by 3 ABC2 and hit equals. And it says 1 5/8. What's that? Second ABC 13/8. That's the kind of thing that you can get out of your fraction calculator. So if you have it, that's helpful, but it's not as good as knowing how to clear fractions. Because if we have an equation we can multiply every term. Every term is the first thing that's important, so I'll underline that once. On both sides of the equal sign, and that's going to get double underlined by me. It's going to look weird. I'll just go like that. You got to do it to every term, and you got to do it to both sides of the equal sign. If you try to do this to an instead of an equation, but rather to an expression, there won't be two sides, so you can't have both sides of the equal sign. But if you're hitting both sides of the equal sign, every term, we can multiply every term by the same value. Don't multiply by 0, that never helps. And the suggestion is you do this. You take the lowest common denominator over 1. And you're thinking, lowest common denominator of what? Lowest common denominator of every fraction you've got. What it will do is create a situation where that number is large enough and has the right numbers in it that it will cancel the denominator of every existing fraction that you have and allow you to continue to work out the problem. So that is what we're going to look at here. We have 2/3 space x plus -5/4 with space before we hit the equal sign. And then finally, -1/6 with actually plenty of space behind it. Let's go find that LCD. LCD of 3 and 4 is 12. 4 is bigger, so it'll get there faster. 4 doesn't divide by 3, double it to 8, doesn't divide by 3, double it, add one more 4 to that and get 12 divides by 3, so you're looking at 12. And of 12 and 6, take 12, which is the biggest one now, 12 and 6 we're looking at. Does 12 divide by 6? Yes, is 12, put it over 1, and that's what we're going to use. 12 is going to be able to divide by 3, 12 is able to divide by 4, 12 is able to divide by 6. So I'm going to put my 12 over 1 in each place as a multiplier, which is a factor. That's why you need the space in each term to have this happen. You're taking 12 times the entire equation, but term by term. Now what happens is always start with the denominator. 3 divided by 3 is 1, 12 divided by 3 is 4. Next. 4 divided by 4, definitely 1. 12 divided by 4 is 3. Next, 6 divided by 6 is definitely 1. 12 divided by 6 turns out to be 2. So now we have this. 2 times 4x plus -5 times 3 equals -1 times 2. These are all going to be 1s now, which means they no longer need to be fractions, which means we can run with this as 8x plus -15 equals -12. See how that happened? Maybe you didn't see it initially. Let me run through it one more time. I put my 12s in place. 12 is big enough and has the right pieces in it as far as factors to divide. 12 divides by 3, 12 divides by 4, 12 divides by 6. 3 divided by 3 is 1, but 12 divided by 3 makes 4. 4 divided by 4 is 1, 12 divided by 4 is 3, 6 divided by 6 must make 1, 12 divided by 6 makes 2. It gives me these. No longer are they fractions. Complete your multiplying. And now we see we have only one x, and it's positive, so I'm good with that. I'm going to add 15 to both sides. And let's see, why did that go that way? No, that seems wrong. It should be 13 over 8. 15, 2/3, x minus 5/4 equals negative 1/6. Okay. 2/3 of 12 is going to be 8. 5/4, that's going to be 15. And that's going to be negative 2. Okay, that's not 12. Doy, that's a 2. So in case I had it written there for a little while you were watching the video, that's a 2. 1 times 2. There. Okay, here we go. 15 plus negative 2 will get me 13. This is already gone. We got 8x equals 13. We divide by 8. It equals that. X is 13 over 8. This is a demonstration with the blue LCD over 1 of what that says we can and should do when we have fractions. Any fractions showing up in your equation, it's got to be an equation so you can do it to terms on both sides. All terms on both sides of the equal sign can multiply by whatever number you want. Multiply by 75 if you want to, but why would you unless 75 is the number that's going to cancel all of your denominators. Some people would think, hey, why don't I just use 3 times 4 for 12 times 6 for 72. That will work, but it's usually bigger than you need, and without a calculator, that's a lot of trouble. With your calculator, it's not as much trouble. It's a few more keystrokes. So that's how we're going to do this, and we'll look at a few examples of it. Then I'll kick you toward the homework on this, which does a bunch of these with fractions and decimals. Now, with decimals, we don't want to have to deal with the decimals that are there either. So the number you can use, if it's fractions, you're going to use the LCD. If it's going to be decimals, since you can use any term you want, it'll be a power of 10, strong enough. So decimals decimal equations use a power of 10. It's 10 or 100, 1,000, however many of zeros, large enough to clear all decimals, so you don't have to deal with decimals. What that means is you find the decimal that has the most decimal digits, and that's how many zeros you put behind your 1 for your multiplier. So if it goes to 2 digits, you're going to use 100. If it goes to 3 digits of decimals, you go to 1,000. If it goes to 5 digits of decimals, should you find that, you go ahead and multiply by 5 decimal digits. Multiply those away, by 5 zeros behind your 1, which is 100,000. It'll still do it. It still keeps in line with what number makes them match. See that time when I multiplied by 12, I just made the target for my new equation 12 higher, but it is still hit 12 times as big, but it's still that they're hitting the same target, they're just hitting a bigger target. And the same thing with powers of 10. So it doesn't change what number makes the balance, they just hit a different spot where they balance and you get the same solution. So I want to try this one. 0.02x minus 0.3 equals 0.07x plus 1.2. Okay, now let's see what happens. If we go without knowing that we can clear the decimals out of there, we would have to go like this. 0.07, 0.02, that's worse, so I would subtract the 0.02x off each side. It's not the worst, but here we go. And this is 0.05x. This can't stay, so I'd say minus 1.2, minus 1.2, and this is gone, and this is going to get me negative, adding them together, I get 1.5, they work together, and strong on the negative like the 1.2. Then I would have to come along here and divide by 0.05. 0.05, 0.05. This will get me x. And now what I have here is negative 1.5 over 0.05. And now, to get that done, I would wind up multiplying the top by 100, but not so much for that, but the bottom one by 100, so I can get my value. Move the decimal twice. It's 1.50, it becomes 150. And this guy, it's negative still. This guy becomes, move the decimal twice, it becomes 5, and we'll get negative 30. So the answer is in there, it's negative 30. But what if I use the 100 right away? 0.02 plus, let's leave space behind each term, plus, which I didn't do right there, doy. Space behind it, plus negative 0.3 space behind it equals 0.07 space behind it plus 1.2 space behind it. I'm going to multiply each term by 100. So I'm going to multiply this by 100. I'm going to make that into 0.30 times 100. So now it has two decimal places, 0.07. That's got an X on it. Times 100. And finally, 1.20 times 100, and it makes it a lot easier to multiply by 100 if I have two decimal digits to absorb. Because now, this makes itself 2 digits larger use of that 2. And it makes me have just, of course, doy. That also has an X on it. And I've got 2x. It's move the decimal twice, I got a 2 with my x behind it, plus. Move the decimal twice, I got negative 30 equals. Move the decimal twice, I get a 7 with an x on it, plus move the decimal twice, I get 120. Now I do my regular old stuff. Subtracting 2x on each side, 5x. This has got to go, minus 120, or negative 120, this is gone. Right, we've got add them for 150, strong on the negative, divide by 5, and x equals negative 30. Got the same thing. We'll see if it worked. Didn't check it either time yet. So we've got 0.02 times 30 minus 0.3. And then we'll have the other one, 0.7 times my x minus 1.2. And see if the two of them make the same value. In there goes my value of negative 30. Plus, here's my negative 30, and plus that. So I'm ready for the terms it's going to make. Okay, got to go 30 times 0.2. So if I did 3, it would be 0.06. It's going to be negative, and it's going to be 0.6. It's going to be negative, and then it's going to have 60, but then I'm going to have to move my decimal twice to make it smaller. So it goes from the 60 down to this. It goes make 60, negative, and move the decimal twice, 0.60. Plus negative 0.3, that's going to get me negative 9 with a decimal point. So negative 0.9. That's one of them. This one, I have 30 times 7 would get me 210, but I have to move the decimal twice. And it's negative. And that was positive right here. So I'm going to change that to positive, plus 1.2. So now as I come here, go plus 1.2. I'll line them up and I'll go 2.1, take away 1.2, which becomes 111. That's 9 decimal, and it's strong on the negative. Those two hit the same target, so yeah, that worked. The one on the bottom, using 100 right away, helped me clear out all the decimals and deal with it with what I'm used to, which to me sounds great. Hopefully we've built the strength in doing the things that don't have decimals, and now we can convert anything with decimals or fractions into a similar type of problem without decimals or fractions. Maybe the answer will have a decimal. Maybe the answer will have a fraction. That's unavoidable. But the way to get the answer is to clear the fractions or decimals out of your equation. So I'm going to put up 3 more examples here in the homework, and then give you the rest of the work to do, which you can do in your homework section. If you need extra help, go ahead and look at the homework video. Here we go. 1/4 in front of parentheses with 3z minus 4 minus 1/3 is equal to 1/4. Here's the z plus 1/6. Okay, I'll write it again. 1/4 times 3z minus 4 minus 1/3 parentheses equals 1/4 z plus 1/6. Now what I should have, let's see, is a little bit of space behind my 1/4 to allow for me to squeeze in my multiplier. Space behind my 1/3, good. Space between my 1/4, and I recommend that it's between the 1/4 and the z, and of course there is space behind the 1/6. Now we gotta go find that LCD. LCD, looking at each denominator that's there. There's a 4 and a 3. 4 and 3. The LCD is going to make 12. There's another 4, so it's the same. 12 and 6. It's going to stay 12. So use 12 over 1. So I'm going to have 12 over 1. Okay, this is plus, negative. Now this in front of the parentheses is where the 12 over 1 goes, and it will get itself into the parentheses later. 12 over 1, because this is where another term starts. This is one term containing parentheses. Until the distributing happens, that's one term. This is a term, negative 1/3 plus 12 over 1 plus 12 over 1. Now that 12 gets to go and reduce like this. 4 divided by 4 is 1, 12 divided by 4 is 3. 3 divided by 3 surely 1, 12 divided by 3 is 4. 4 divided by 4 surely 1, 4 divided by 4 is 1, 12 divided by 4 is 3. 6 divided by 6 is surely 1, 12 divided by 6 is 2. So now let's see what we've got. 1 times 3 is z plus negative 4 plus negative 1 times 4 equals 1 times 3 with a z plus 1 times 2. No more fractions. This is going to get me 3 times 3z plus negative 4 plus negative 4, right, close the parentheses here. This is equals 3z plus 12. Great. 12, no, I did that again. Wow, that looks 12-ish. It's a 2 this time. Okay. Fairness, in case you had the 12 written right away, better fix that. It's at least going purple. Got to get rid of the parentheses. 3 times 3, 9z, plus 3 times negative 4 is negative 12, plus negative 4 that was already there. Here we have 3z plus 2. Combining like terms. I would do this, right? Cover that up. 9z plus negative 12 plus negative 4. The negative 4 is in the same column as the negative 12. We go 9z plus negative 16 equals 3z plus 2. The 9z is better than the 3z. Let's get rid of the 3z. Subtract 3z off each side. Gone. You cannot stay. Plus 16, plus 16. Okay, you're gone. This is 6z. Long equals 18. Divide by 6, divide by 6. Z equals 3. 3 should go in and make things happen in the very original equation. So 1/4 times 3 times 3, let me get my blue 3 in here. Minus 1, close the parentheses, minus 1/3. Okay, let's see what that makes. Without the calculator, I'd have to go with 1/4 times 9 minus 4 minus 1/3, which is 1/4 of 5 minus 1/3. 1/4 of 5 minus 1/3. 5 goes over 1, we're going to get 5/4 minus 1/3. Then I would have to go to check this out. Need 12s on the bottom of each. 12 divided by 4, let's use 3s. That's 15. 12 divided by 3, that means 4s. That's a negative 4. 11 over 12. That's what I have to do on that side. And now the other side says that I've got 1/4 times my number plus 1/6. And my number wants to go in as 3. 3 over 1, good. 3/4 plus 1/6. 3 over 4 plus 1/6. Now they each need to be over 12. 12 divided by 4 is 3, gets me 9. 12 divided by 6 is 2, gets me 2. 9 plus 2 over 12, 11 over 12. And it worked. I'm going to reinforce how good it is to have a fraction skill calculator and to work with it. Every time I see a fraction, I'm going to hit the ABC key. So here's what we have. We have 1 ABC 4 times parentheses where I have 3 times 3 minus 4, close the parentheses, and then minus 1 ABC 3 equals 11 over 12. Now I'm going to do the same thing. Over here, I'm going to put in 1/4 times 3 plus 1 ABC 6 equals 11 over 12. Not only did they match each other, they got the same thing that I found here. So that's what you can benefit from knowing how to use your calculator that handles fractions. This is how we cleared the fractions. Notice what happens when there are parentheses in front of the parentheses, but behind their coefficient is where we put our multiplier, and it'll get to them as part of the single term that contained the parentheses initially, and it'll get the job done. 2 more problems on this. One with fractions, one with decimals, and then I'll set you off to do the homework. Let's take on 3z minus 2 all over 6, and that's equal to a plain old 4 minus 2z minus 1 all over 3. Now what's that got for me? I'm going to put parentheses around my 3z dash 2, and that's over 6. And then insert a plus sign, right, instead of having minus. Boom. Okay, equals 4, that's going over 1, because 4 over 1 is going to allow me all the pieces I need to work with a fraction. I have this dash, so let's see how I'm going to do this. I'm going to put my plus, and then I'm going to put my dash, then I'm going to put a 1 before I put parentheses around the 2z minus 1, which of course the minus 1 is going to become plus negative 1. And it's been the whole time over 3. LCD for 3 and 6 is going to be 6. What happens is LCD of 3 and 6 equals 6. Because 6 is bigger, 6 divides by 3, that's perfect. So it's going to be 6 over 1. So I'm going to put my 6 over 1 right in here, and then here there are 3 terms, 1 on the left and 2 on the right, and I'm going to do all that multiplying and canceling. 6 divided by 6 is 1, 6 divided by 6 also makes 1. 1 divided by 1 is 1, 6 divided by 1 is an unchanged 6. 3 divided by 3 is 1, 6 divided by 3 is 2. And what I have is weird in a way because behind the parentheses we might have a number coming up, such as 3z plus negative 2 all times 1, right? I'm going to move the 1 out in front because it's multiplying and it's easier for our distribution, but it is times 1, equals 4 times 6 is straight to 24, plus, I'm doing black straight across right here, that plus sign, here's my negative 1, and here's that 2, which I'm going to move out here by the negative 1, and here comes my 2z plus negative 1. But you'll notice all 1's in the denominator means I don't have fractions anymore. This becomes, distribute the 1, 3z plus 2 plus negative 2 equals 24 plus negative 2 times the parentheses 2z plus negative 1, which is going to get me negative 2 times 2, negative 4z plus negative 2 times negative 1 is going to get me positive 2. But what happened was I was able to get the -1 times 2 to become -2 times 2 for 4 on the z. -1 times 2 is -2 times -1 for the +2. Everything's there. Time to combine like terms. No like terms here. There's a number. Here's a z. Here's a number. This 24 is going to get the +2. We have 3z plus -2 equals 26 plus -4z. Where's the worst bank balance? Definitely there. Let's add 4z, both sides. That's gone. That means this is where my 7z will appear. This can't stay, so +2 plus 2 gone equals 28. Divide by 7. Z is 4. It's like 4 is what I got. So I'm going to check that by putting 4 into there. It's going to get me 3 times my number minus 2 over 6, and that's supposed to have a 4 for z. Okay. Go plus negative, and we're good. What's that make? 12 minus 2, 12 plus -2 over 6, 10 over 6, divide by 2s, we got 5 over 3. That's the target that it seems to be hitting. Now we go to the other guy where he's got 4 over 1 minus 2 times my number minus 1 over 3. My number goes in as 4. Trying to hit eventually 5/3 as our target. Let's see. 4 over 1 plus negative parentheses around 8 minus 1 over 3. So this is 4 over 1 plus -7 over 3. 4 over 1, and that's over 3. I need them both over 3. So the 7 over 3 is already over 3. 3 divided by 3 is 1. We hit them each with 1s. They stay with -7. And here we got 3 divided by 1 needs a 3 here and a 3 there. We get 12. Okay, put one single 3 with 12 plus -7, and you're going to get 5 over 3. It did hit. That's perfect. Z equals 4. Wait a minute. Let's grab this calculator so we don't have to do all that stuff. This didn't need the fraction function of the calculator, but this did. So if I go here where I take on the top, and I'm opening parentheses, I'll put 3 times 4 minus 2, close my parentheses, the top is done, and then put ABC and hit a 6 and equals. Let's see, try that again. Parentheses, 3 times 4 minus 2, close the parentheses. That creates my 10. It's visible here. ABC 6 equals. Okay, so now what I'll do is I'll take the 10 and go 10 ABC 6. This calculator apparently couldn't quite handle it. 10 ABC 6 equals, it says 1 2/3. I'm going to now hit second ABC, and it says for me the 5/3. So it got what I need. And go on the other side where I had to do 12/3. Well, I have to do this whole thing. 4. And when I get there, I'm going to put in a 4. So I'm going to go 4 minus parentheses contain 2 times 4 minus 1 close ABC3 equals. Well, that didn't seem so good. Let's try it. Let me do the fraction instead. Parentheses, let's see, clear. Parentheses, 2 times 4 minus 1, close the parentheses. It's got me the 7, which is this 7. ABC3, let's see how it handles that. Not too well. So I'll take my 7 and I'll go ABC3. That's what I have for my fraction, 7 ABC3. This part, I'll go with 4 minus 7 ABC3 equals 1 2/3. And I'll hit second ABC, and it's also the 5/3. So that wasn't as lovely as it's been in other cases. The only other one we got to deal with is a decimal problem. So we cleared the fractions there, and we put parentheses around the multiple term numerators, right? It's got more than one term in the numerator. We want to throw it in parentheses, as we often do with fractions. so that when we go back to it, it takes the whole numerator and does right by it. Last one is one with decimals and parentheses. 17 plus 0.25p equals 0.1 times 50 plus p. Okay, I'm going to rewrite it. 17 space 0.25 space p equals 0.1 space 50 plus p, which is actually 1p because it's behind that plus sign like that for distributing. Let's see what we need here. No decimal places, 2 decimal places, 1 decimal place. The most I heard was 2 decimal places. It came from this one. 2 decimal places is what I'm thinking. So now I make sure that every one of my numbers before I get going has 2 decimal places. Now it does 0.00, 0.25 is good, 0.10 is good. Now I'm going to come through and multiply each one by 100. And by 100 we'll multiply, this type of multiplying will move the decimal to make it bigger twice. So now what we get is we get 17 with 2 zeros, then the decimal, then we get 25, it's absorbing the 100, this absorbed the 100 with multiplication, times p equals 10, right, we get the 0.1 times 100 is going to get us 10, and we have 50 plus 1p. This won't take long to finish, and we'll see what kind of number we get. We've got to distribute that, right? So 1700 plus 25p stays, but 10 times 50 is 500, plus 10 times 1 is 10 with a p. And we go to get rid of the worst bank balance, which is the 10p, not the 25p. Minus 10p, minus 10p. Gone. 15p. Sir, you cannot stay. 1700 minus 1700 equals, make that neat enough to read. Okay. Negative 1200, divide by 15, divide by 15. Let's go. Clear. 1200 negative ABC 15 equals negative 80. That's what they think it is. Now we got decimals. So we go with 17 plus 0.25 times 80. Okay. That's 17 plus a quarter of 80 is 20. That makes 37. The other side we have, let's see, 17 plus 80 makes 37, right? Let me just see. Let me just do it on here. 17, first we'll try 12. Oh, 80 is negative, doi. Negative 20. And then subtract for 3 that's negative. Okay. So let me fix that. I had negative 80. Therefore, this 80 will go in as negative 80. This 20 will go as negative 20, and we'll get the target of negative 3. Okay, other side. We have 0.1 times 50 plus negative 80 goes in. To free the negative 80 from its parentheses, I have my 1, and we're ready. I like it. 0.1 times 50 plus negative 80. 0.1 times 50 minus 8, 80 minus 50 will get me a 30 strong on the negative. 0.1 times 30 makes into negative 3, and the targets are the same, and it works. The key here on, of course, don't make mistakes in copying or bringing over the negatives, but the other key on this work is we needed to move 2 decimal places to take care of that, so they all move 2 decimal places. Recommendation, make sure every term has 2 decimal places before you multiply by 100. It'll make it easy to make the moves, create the new terms. That should set you to going right into homework 9. Good luck with it. Give you a time total in our